Hi everyone, this is Capsule, a marketplace for verifiable private knowledge. The core problem we are solving is very simple. Today, if someone sells you a section from a private report, a research dataset, or a trading strategy document, they can simply copy paste anything. As a buyer, you have no way to verify whether that section actually came from the original document, whether it was edited, or whether it was fabricated. At the same time, the publisher may not want to reveal the entire document. A researcher may only want to monetize one section of a dataset. An AI agent may need a few verified training or evaluation samples, not the full private source. A capsule solves this by letting publishers commit a document once, keep the full source private, and sell only selected sections. The buyer receives the purchase fragment along with the cryptographic proof that verifies it against the original on-chain commitment. So instead of trusting the seller's copy paste, the buyer verifies the content mathematically. And this is the capsule artifact that the buyer receives after buying it. So let me quickly walk through how the system works. At the storage layer, we use Walrus. The actual private data is too large and too sensitive to store directly on chain. So Capsule stores encrypted fragments and encrypted delivery capsules on Walrus. Walrus gives us a durable, retrievable off-chain artifacts. At the blockchain layer, we use SUI. SUI stores the document commitment, fragment references, purchase receipts, payment provenance, and disclosure records. So the important proof and payment state is public and auditable. For access control, we use seal. The publisher encrypts fixed sellable sections before upload, and seal releases decryption material only when the buyer's wallet satisfies a SUI move access policy. And finally, for authenticity, we use Merkle proofs. Every line of the document is committed into a Merkle tree. When the buyer purchases a section, they receive only that section plus the proof needed to recompute the root. If the recomputed root matches the root stored on SUI, the buyer knows the fragment belongs to the committed original document. Now let me show you the architecture. The publisher starts in the React frontend. They enter a line-oriented document and pricing. In the recommended flow, the browser builds the Merkle roots and proofs, divides the document into fixed sellable sections, and seal encrypts each section locally. This is important because the host receives only ciphertext and public metadata, not the full plain text document. The disclosure host then uploads those encrypted fragments to Walrus and registers the document and fragment objects on SUI. The marketplace API stores metadata like listings, pricing, purchase references, and public audit information, but it is not trusted for cryptographic validity. The source of truth remains SUI plus local proof verification. On the buyer side, the buyer browses the marketplace, selects a fragment, and signs a SUI transaction using purchase fragment. This creates a paid purchase receipt that is bound to the exact fragment. The host validates that receipt, retrieves the encrypted fragment from Walrus, records disclosure provenance on SUI, and returns the encrypted capsule. Then the buyer authorizes a seal session. Seal checks the SUI move policy through seal approve fragment. The policy verifies that the requesting wallet is the buyer, that the purchase belongs to the same document, that it is bound to the exact fragment, and the range and the seal identity match. Only then can the buyer decrypt locally. After encryption, the browser verifies the Merkle proof locally. It does not ask for our backend whether the content is valid. It recomputes the root from the disclosed content and proof path, reads the public document root from SUI, and checks that both match. This is the code trust minimize guarantee of Capsule. Now I'll show the code base quickly. Yeah. The project is a mono repo. The front end handles publisher, buyer, and verification experience. The marketplace API handles listings, prices, receipts, and PostgreSQL persistence. The disclosure host coordinates Walrus uploads, SUI submissions, and paid delivery. The agent MCP server exposes read-only tools so AI agents can list documents, fetch capsules, and verify them safely. In packages, we have shared protocol types, a TypeScript SDK for browser and node verification, a Rust engine with WASM exports for canonical Merkle operations, and the SUI move contracts that define document, fragment, purchase, and disclosure objects. Now let me demonstrate the product. Here's the landing page for our project. Now I'll connect my wallet. My wallet is now connected. Here we have a marketplace seeded with realistic private knowledge examples like legal research, market intelligence, AI evaluation, and so on. I'll encrypt a few lines for me, and I'll click on play and disclose. This transaction calls purchase fragment, transfers the payment to the publisher, and records that my wallet is authorized for this exact section. When the payment is confirmed, the capsule asks the disclosure host to generate a delivery capsule. The host validates the SUI purchase receipt, fetches the encrypted fragment reference, uploads a delivery wrapper to Walrus, and records disclosure provenance on SUI. So my transaction is now confirmed, and this second signature is not another payment. It authorizes a short-lived seal session for decryption. Seal uses this wallet session to check the SUI access policy. The content is now decrypted locally in my browser. The server did not reveal the full source document, and it did not decide whether this content is valid. Now I verify the proof capsule. The browser recomputes the Merkle root from the disclosed lines and proof path. Then it compares it with the root stored on SUI. So my proof is valid. This means the fragment I bought is cryptographically included in the publisher's original committed document. I did not have to trust the seller's copy paste or the backend. Now I am unlocking it with seal. Seal checks seal approved fragment on SUI and verifies that this wallet is the buyer, the purchase matches the document, and the purchase is bound to this exact encrypted fragment. Since I bought this fragment with the same wallet, it should, yeah. And so we have the proof capsule here with us, and this is our submission for the Walrus track of SUI Overflow 2026 hackathon. And thank you.